All right, you left it a little bit of practice yesterday on finding square roots and using the imaginary number I. Remember that I is equal to the square root of -1. So the line of thinking when you're looking at a problem like this, we're going to break out every time a -1 factor and then look for perfect square factors to pull out. The square root of -1 is I. The square root of 49 is 7. I'd like to express this as 7I. Number 2, same strategy, factors and -1 is a factor in perfect squares. 4 is a perfect square. The square root of -1 is I. The square root of 4 is 2. Number 2 is 2I. Number 3, breaking down factors, -1 is a factor. 45 is not a perfect square, but it can be expressed as 9 times 5, where 9 is a perfect square. I'm going to pull out the square root of -1 as I, the square root of 9 is 3, and I'm going to leave 5 underneath the radical. The simplified answer would be 3I root 5 for number 3. Number 4, I've got -2 on the outside of our radical sign. I'm going to leave that out there. I'm going to expand my radical by factoring -1 times 100. 100's a perfect square, so -2 stays outside times the square root of -1 is I. The square root of 100 is 10. So then I'm going to simplify this to -20I. Number 5, I'm going to leave 6 on the outside. I'm going to, underneath the radical, factor my -1. 121 is a perfect square. 6 times I times 11. The square root of 121 is 11. My simplified answer is going to be 66I. Number 6, 5 on the outside times the factors of 75 that I know I can pull out, -1 times. Now 75 has a perfect square factor of 25. I'm going to write that as 25 times 3. I've got 5 times I times 5 with root 3 remaining. The I represents the square root of -1. The 5 is the square root of 25. 5 times 5 is 25. I root 3 is the simplified answer for number 6. And then I also had you working on 9, 10, 11, and 12, which is just a matter of using the distributive property and combining like terms. And then we'll talk about the classification as real or imaginary numbers and pure imaginary numbers. In number 9, I see there's a plus sign between the parentheses. There is nothing that needs to be distributed to either set of parentheses, so I'm just going to rewrite this expression without parentheses. And then I'm looking to combine my like terms. -8 and -1 is going to give me -9. Positive 3I minus 2I is going to give me positive I. So -9 plus I. Now in number 10, I see I can remove the parentheses from the first group, no problem, but I do have to consider multiplying through a -1 through the second set because it's subtracting the quantity. So removing the first set of parentheses, 36 minus 3I, -1 times positive 12 is -12, -1 times positive 24I is -24I's. Combine like terms, 36 minus 12 is going to give me 24. -3I minus 24I is going to give me minus 27I's. Number 11, plus sign in between the parentheses, nothing to be distributed. So I'm just going to write this the way it is without the parentheses. Plus -16 is the same as subtracting 16. What I notice here is that my 16 and -16 are going to cancel out, so I have I minus 8I, which is going to leave me with -7I's. Now number 12 is much like 10. I see I'm going to have to distribute a -1 through the set of parentheses, the second set. -5 minus 5I. -1 times -6 is going to give me +6. -1 times -6I plus 6I. Then combining my like terms, -5 and 6 is going to give me 1. -5I plus 6I is going to give me a 1I. So 1 plus I. And we'll go back and start talking about classifying in class.